Let's work our way through this handout, writing equations for graphs of trigonometric functions. We've done some of this before, but this example is really different from what we've looked at before, because we're gonna find an equation for this graph, and what's different is we're seeing a lot of the wave being graphed here. Up to now, we found equations where we've seen just one period of the graph. Here we see several periods of the graph drawn, and so it's a different kind of challenge trying to find an equation than what we've seen before. After we do this example, on the back side or the second page of the handout, there are three graphs for you to do on your own, and I'll give you those answers. Consider these three as homework problems. We'll do this first graph together, and that should be enough for you to be able to do the three homework problems on your own. This is an important skill. This is kind of the culmination of our ability to look at a graph and come up with an equation for it. Now, on the scale's a little bit hard to read on this grid. I think the y-axis scale is pretty clear, 0, 1, 2, 3, 4, 5, 6. But the x-axis scale is not showing up really well. So just notice right here is 1, right here is 2, here's -1, -2. We need to see those x values so that we can work with the scale on this grid. We gotta choose. Do we want to use the sine function or the cosine function to describe this graph? And really, you could always choose either one. Sine will work or cosine will work for any sine wave. It turns out, in my opinion at least, I think it's almost always in this kind of situation easier to choose cosine. So I'm going to work with cosine here, and we'll as we go through, we'll talk a little bit about why that seems easier. And yet, when I give you the answers, I'll probably give you answers for both sine and cosine. And really, right at the beginning here, we're going to now start trying to identify values for the constants, right? The a, b, c, d values. It's really right at the beginning when I can give you a reason for choosing cosine. We need to find one fundamental period of the graph to work with. And to do that, it's a lot easier to think in terms of cosine, where we tend to measure a period from like a high point to the next high point, from a max point to the next max point. In fact, I can already label this picture from here to here. That's going to be one period of this graph. That's one period if I'm focusing on thinking of this as a cosine function. If I wanted to use sine, I would have to locate kind of a midpoint on the graph and think of that up, down, up shape to get one period. That's a little bit more difficult to do. It's possible, but it's a little bit more difficult. It's much easier to just look high point to high point to measure one period of the graph. So that's really my reason for choosing cosine over sine. Now let's maybe get back to the steps here as outlined on this handout, because the question on the handout is they're asking us first to determine the amplitude of this wave, and the amplitude is going to give us our a value that we want to work with. The amplitude is not 4. You might kind of want to jump to the conclusion that 4 is the amplitude, but it's not 4 because there's actually been a vertical shift of this graph. It's not centered right on the x-axis. There's been a vertical shift upward. So if really if you can find the midline and then find the distance from the midline to the top, that would give us the amplitude. In this situation, where the wave could be just all over the place on the graph grid, it's nice to know that there's this formula. Some of you might want to use this formula to calculate the amplitude. You can get it by taking the max value minus the min value and divide by 2. The max value on this graph is 4 minus the min value occurs at y equals -2, so we'd have to do 4 minus a -2, and then divide by 2. What that does is 4 minus a -2 measures the total height of the wave. 4 minus a -2 is 6. But the amplitude is half of the total height, so 6 divided by 2 is 3. The amplitude is 3. And so this max value minus min value divided by 2 gives us a way just to pluck numbers off the graph and get to that amplitude value, a little shortcut. So you can sometimes just eyeball it, figure that out, but if it's not so obvious where that 3 came from, you might want to rely on this formula. Now, the amplitude is 3. We have to choose our A value. A could be positive or negative. A could possibly be +3 or -3. Because we're setting up the function here, we can kind of make A come out to be what we want. If I choose a fundamental period from a max point to a max point, I'm going to base my formula on the y equals +1 cosine x graph, plus cosine x graph. So I can make A be positive. In fact, you can always choose A to be positive in these problems if you want. You could also always choose A to be negative if you wanted to measure a period from low point to low point, min point to midpoint. There's a way to use -A, but why do that? Why? Of course, we want A to be positive if we can. As long as we work from high point to high point, we can choose a positive value for A. Okay, next we want to find the period of the graph. We're going to use the formula that the period is 2 pi over b then, and that will help us get our b value. So first we got to figure out what one period actually is. We know it's from here to here. I think we got to figure out what the distance is between tick marks on this graph. So you kind of have to go down to the x-axis here and count 1, 2, 3, 4, 5, 6, 7, 8. There are 8 spaces between 0 and 1, so don't make the mistake of thinking this is like, it's not 0.1, 0.2, 0.3, 0.4. It's actually eighths, 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. So each tick mark is spaced 1/8 apart. So we're going from 1/8 to 1 1/8 is the distance from here to here. Now, because we go from 1/8 to 1 1/8, the total size of the period is 1, 2, 3, 4, 5, 6, 7, 8/8. One period is just going to be 8/8 or 1 unit. And you can eyeball that, or you could subtract 1 1/8 minus 1/8 to get 1. That's the size of the period. So the fractions get a little messy, but the period is exactly 1 unit from here to here. And so now if I used my, let's see, period equals 2 pi over b formula, the period is 1 is equal to 2 pi over b. I guess I should fill in the 1 here. Sorry, that space was meant to be for the period. I'm already going ahead and solving for b, multiply both sides by b. b is equal to 2 pi here. So I have an a value and a b value. Period is 1, but the value of b will be equal to 2 pi. Now we still got to get a c and a d on this. This handout, they talk about vertical shift next, so we're looking actually for our d value next. And it's a little bit subtle what the vertical shift is. So if you want, you can use this formula to figure out what the midline is. If you can eyeball it, you might be able to see where the midline is on this graph. I hope you can kind of pick out where it is. But when it's hard to see the midline, or when it's not clearly labeled, you can use this max value plus min value divided by 2. What we're doing here is we're taking 4 plus a negative 2 divided by 2. It's like we're taking an average of the max value and the min value. The average is going to be exactly halfway in between. This is going to be 2 over 2, or 1. So the horizontal line y equals 1 is the midline. So here the difference is we're adding the max value to the min value, dividing by 2 to get the point that's halfway in between. That's different from the amplitude calculation where we found the total distance between the min point and the max point and divided by 2. So make sure you keep the amplitude formula and the midline formula distinct in your minds. So we can see the midline. I could just draw it in here. And on this graph, you might have been able, I bet you could have guessed that without even doing the calculation. Midline is y equals 1. And so the nice thing about finding the midline is that helps me see the vertical shift, right? The midline measures how far we've shifted vertically, because the midline would have started out on the x-axis. It shifted up 1 unit. So our vertical shift is up 1. And that means our d value is plus 1. So we got our d. All right, now we're ready to work on the phase shift for the graph. Because I chose my period starting at this high point, I've shifted away from the y-axis by this much. The whole graph has shifted over just a little bit, right, to the right. And our phase shift from the perspective that I'm taking is 1/8 to the right, that way. So the phase shift is 1/8. And I can use this formula that the phase shift equals c over b to plug in the phase shift of 1/8 equals c over, I also have to plug in my b value of 2 pi to solve for c. Like we've talked about before, there's an alternate way to do this where you work with parentheses and factoring out the b value from the expression. You actually go the reverse of factoring out to get back to the c value. And I'm not going to write that out here. Here I could cross multiply. I get 2 pi equals 8c. 2 pi over 8 is equal to c, so pi over 4 is equal to c. There's my C value. Okay. And now I'm ready to write the equation. I'm going to use the cosine formula. So I'm going to write y equals a is 3 cosine. Bx is 2 pi x minus c is minus pi over 4 plus my d value is 1. And there's the answer.